I hope you're doing well today. In this video, we would like to talk about the conditional and then related statements. Now, from the last lecture, you'll recall the conditional is if P, then Q. I've got it listed first here, the conditional statement, if P, then Q. You could also read P implies Q. But then I've got something new called the converse listed second. And notice that's if Q, then P. Notice this is reversed. So we took the conditional if P, then Q and reversed it and said if Q, then P. And then third, we have the inverse. And the inverse, notice, is not P implies not Q. Or you could read it if not P, then not Q. And then lastly, we have this crazy thing called the contrapositive. And that would be if not Q, then not P. And notice what happens is the contrapositive is both the converse and the inverse combined together. And if you'll see down below from Miss Missy Elliott, I put my thing down, flip it, and reverse it. You may recognize that as the words from Work It. And this is silly, but I think this might help you remember this. So Missy's thing is the conditional statement. She flips it by taking the inverse. So the inverse is the flipping it. And reverse it, that's your converse, right? When you reverse the order. And when you do both of these, you put your thing down, which is your conditional statement, and then you flip it and reverse it, you get the contrapositive. And there's something really important about the contrapositive, and we'll talk about that in just a minute. So I want you to think about the statement, if you lead, then I will follow. So clearly that's a conditional statement because it is an if-then. If you'll remember, every if-then statement or every conditional statement, let me say it that way, is not written as if-then. Sometimes you have to reach in there and turn it into an if-then. But if you can and it makes sense, then it is definitely a conditional statement. So we take the statement, if you lead, then I will follow. And I want us to write the converse, the inverse, and the contrapositive. So let's start with the converse, right? And the converse is you switch them around. So if you lead is our P statement, because that's the way it's set up for the conditional statement. So this is my P statement. Then I will follow is my Q statement. So the converse, I switch those around. If I will follow, then you will lead. Right? If I will follow, then you will lead. That's my converse. So what about the inverse? Notice the inverse, if I remind you, is when you flip it. In other words, you negate it. So you say not P implies not Q. So the order stays the same as the original condition statement. So if I say if you do not lead, then I will not follow. Does that make sense? You keep the order the same for the inverse. You just negate both statements. So if you do not lead, then I will not follow. And of course, that can vary just a little bit in the words that you choose and still have the same meaning. And finally, the flip it and reverse it, right? The contrapositive. I need to negate both the P and the Q and flip it around. So if I flip it around, the Q comes first. If I will not follow, then you will not lead. Does that make sense? That's the contrapositive, okay? If I will not follow, then you do not lead, or you will not lead. Either way that you want to say it is perfectly fine. So you see how this works? Now think about the truth value of this situation. You know, conditional statement, if P then Q. If you flip it around and find, not flip it around, but actually reverse it, and you find the converse, if I will follow, then you will lead, that doesn't necessarily sound like it would be true if the original one was true, right? Or if you do not lead, then I will not follow, that doesn't necessarily sound true either. But you know what? The contrapositive, if I will not follow, then you do not lead, kind of makes sense. If you lead, then I will follow. Then if I will not follow, that means you're not leading, right? So keep that in mind as we go through and try another one of these. So another statement, consider vegetables contain micronutrients. Now, you might not get that that's an if-then statement at all. I could see where, it's just a fact, right? Vegetables contain micronutrients, and they do. But how could we even turn that into an if-then statement? Is this even an if-then statement? I think so. If it is a vegetable, then it contains micronutrients. That's really what this is saying, right? Vegetables contain micronutrients. So if you have this thing and it's a vegetable, then it contains micronutrients. It's saying exactly the same thing. So we can write this as an if-then statement. And there it is. If it is a vegetable, then it contains micronutrients. So sometimes you have to dig deep and turn your statement into an if-then statement. And everything can't be done like that. So it really has to be a conditional statement. Now, I want you to maybe pause it and see if you can't determine the converse, the inverse, and the contrapositive. So I want you to reverse it, flip it, and do both. Flip it and reverse it. Now, how about the converse? Okay? If it contains micronutrients, then it is a vegetable. Notice the converse is just reversing what we're saying. If it contains micronutrients, I put my Q first, then it is a vegetable. Now, think about the truth of that. Do you think that makes sense? If it contains the micronutrients, then you can automatically assume it's a vegetable. I say not. There are other foods that contain micronutrients that are not vegetables, like a fruit, for example. All right, let's try the inverse. Remember what the inverse is? That's the flip it, right? So we're going to find the inverse, and the inverse, you just negate both of your statements, but you keep them in the original condition statement order, okay? So if it is a vegetable, then it contains micronutrients. If I negate it, if it is not a vegetable, then it does not contain micronutrients. How does that sound? If it is not a vegetable, then it does not contain micronutrients. And that is definitely the inverse. We negated both of the statements. We kept the original conditional statement in the order that it's supposed to be in. We just negated. Now, what do you think about the truth value of that? If it's not a vegetable, then it does not contain micronutrients. Now, once again, what about a fruit, right? The fruit's not a vegetable, but it definitely contains micronutrients. Some of them very many, like a blueberry. Okay? So, it sounds like the converse and inverse, we have some truth value, a problem, right, compared to the original. Now, let's see if we can do the contrapositive. Remember, that's Missy's. We'll put a thing down, which is our original conditional statement. We're going to flip it and reverse it. Okay, so if we flip it, we make them both negative, just like the inverse. It is not a vegetable, then it does not contain micronutrients, but we also reverse it. All right, so it does not contain if it does not contain micronutrients, then it is not a vegetable. Okay, if it does not contain micronutrients, then it's not a vegetable. Now, what do you think about the truth value of that? If it does not contain micronutrients, then it is not a vegetable. You know what? That sounds kind of like the original, right? Because we said that vegetables contain micronutrients, so if you have this thing that does not contain micronutrients, you know right off the bat it's not a vegetable, because we know that vegetables contain micronutrients. Is this sort of making a little bit of sense? I hope. Let's keep going. All right, so now we're going to create truth tables for the conditional, the converse, the inverse, and the contrapositive. And if you are checking my spelling, which I swear I edit these before, but I think I even fixed this at some point, but it didn't stick. Converse does have an E on the end of it. So anyway, so we're going to create truth tables for the conditional, the converse, the inverse, and the contrapositive. Here we go. I went ahead and made a table for you. There's where I fixed the converse. Okay, so I made a table for you. So we have a column for P, column for Q, right? Here's my conditional. Here's my converse. Remember, that's our reverse it. Here's our inverse. That's our flip it. And here's our contrapositive, which is flip it and reverse it. Now, let's create some truth table here. You want to? So I got my black pen. I'm going to stick with that. Now, remember, if you have a P and Q and that's all you have, then you have 2 to the second power, which is 4 rows. When you have 4 rows, you split that in half, right? And you do 2 T's and you do 2 falses. That's where you start. So I got 2 T's and 2 falses, or 2 trues and 2 falses. And then you take that 2 and split it in half, and then you have a true false, and split in half you have a true false. You with me? So true false, true false. Now we do if P, then Q. Now you'll have to rack your brain a little bit and remember, what about the truth values for if P, then Q? What's important there? Okay, well, the truth value of P matters a lot, right? If true, then true definitely results in a true statement. But if true, then false, that means the statement was a lie, right? If the first thing happens, but then the outcome does not happen, that is definitely a lie. But then we decided when we did these that if false, we really don't know what should happen after that. So that was true and that was true. So if you have false first in a conditional statement, then the outcome is true. Now the converse, we're reversing it, right? Flip it is the inverse, converse is the reversing it. And it's got the word verse right there in it. Well, they both have the word verse, don't they? So that doesn't help. Anyway, so QP. So I'm going backwards. True implies true is true. False implies true is true, right? Because if you have a false with your initial statement there and implies true, that's true. True implies false, that's your false one, okay? False implies false, that is true, because if your initial, your antecedent, right, is false, then automatically it's false. Now, how about if we negate the P and Q? And you know what? I should have done a column for negation, right? So we needed to negate P and we needed to negate Q. And I wasn't using my brain when I did this. Okay, so here we go. So let's do a column for not P, which is going to be false, false, true, true. Just sneak it in there. And a column for not Q, right, which is going to be false, true, false, true. Remember, when you negate something, you just change the truth value. So if I do not P implies not Q, what am I doing? Remember, if thens, true, true is true. True, false is false. And if you start with a false, it's always true. So look here. I'm starting with a false. False implies false. I'm using my red ones. That's going to be true. False implies true is true. True implies false is false, right? That's the only one that's false. True implies true is true. Okay, now I'm going to flip it and reverse it. So not Q implies not P. So I'm going backwards. I'm looking at my not Q first and my not P second. So false implies false. That is true. True implies false. That's the only time it's false. False implies true is true. True implies true is true. There we go. Now why did we do all this? Well, there's something I want to show you. Look at the outcomes for conditional, converse, inverse, and contrapositive, these four, okay? If you look at what matches, you'll notice that the converse and the inverse have exactly the same columns here. They have the same truth value. The converse and the inverse have the same truth value completely. But also, look at the conditional and the contrapositive. They also have the same truth value. So your conditional statement, if you restate it as a contrapositive, in other words, flip it and reverse it, then you get exactly the same truth value. And I think you could kind of see that when you did the vegetable statement. If we go back and take a look at that real quick. Look, your original statement says, if it is a vegetable, then it contains micronutrients, when we wrote it as an if-then. The contrapositive says, if it does not contain micronutrients, then it's not a vegetable. That's exactly the same statement, but with the same truth value. It's a different statement, right? It's the contrapositive, but these are equivalent. Also, the converse and inverse are saying the same thing. If it contains micronutrients, then it is a vegetable. That's not necessarily true because we talked about the fruit. If it is not a vegetable, then it does not contain micronutrients. It's the same idea. You know, what if it's a fruit? And so those have the same truth value as well. We proved that from the truth table, not from that statement. That statement just made it seem that way, but the truth table really proves it to us. So here, a conditional statement and its contrapositive are equivalent. Also, the converse and the inverse are equivalent. We said that already, but this last line right out of the book makes it official, I guess you could say. All right, so similar to homework, they give us an if-then statement, and this one happens to be if not P, then Q. Now we're supposed to write, we're supposed to write the converse, and then we're going to write the inverse, and finally the contrapositive. So the converse is actually the reverse it, right? And I wish this was in the same order as Missy's song, but it's not. So it's reverse it, flip it, and then flip it and reverse it. Okay? So the converse, again, is, and I put the cheat sheet right down here at the bottom, you reverse the order. Okay? So Q implies P this time. So our Q in our particular problem is Q, right? So Q implies not P. So all we did was reverse it. That's what the converse is reverse. Okay, converse is reverse. Inverse is the flip it. So I take my original over here and I negate both of them. I keep the order the same. So not P negated, and if you really want to write it, it's not P, right? Implies not Q. But that's not simplified because not P, of course, is P. So this is P implies not Q. And that's the final answer, whereas for the converse, that's the final answer. And now we want to do both. We want to find the contrapositive, which remember the truth value of the contrapositive is original to the initial conditional statement. We do both, right? We flip it and reverse it. And this one has already been flipped for you. You can just reverse it now and say not Q implies P. Okay, or you could do all the work. So reverse, so Q implies not P and negate both. So not Q implies not P, and that gives me not Q implies P, just like we got. What do you think? You could do this. You're just following these steps right here, cheat sheet at the bottom right hand, the definitions of these related conditional statements. Why don't you pause it and try it again? I'm asking the same thing. I'm asking for the converse, the inverse, and the contrapositive. So the converse is reverse. Reverse the two statements. So that's not P implies not, I can't get my not right, not Q. Okay, so that's the reverse it, converse. And then the inverse is the flip it. So I keep the order of the conditional statement the same. I negate both statements. So that's not Q implies not P. Of course, I know you know that's Q implies P. Done with that, right? So that's my answer here. That's my answer here. And then Missy's contrapositive. So I'm going to flip it and reverse it. And again, what I like to do is I take my flipped it and just reverse it. So take your inverse and then reverse it. So that's P implies Q. Hey, pause it, check it, redo it yourself, make sure that makes sense, okay? Next, I want to talk about statements that are not necessarily written clearly as conditional statements. If P, then Q makes it real clear. But what about our vegetables contain micronutrients? That is clearly not a conditional statement. I mean, it's not clearly a conditional statement. It is a conditional statement, but it's not clear that it's a conditional statement. So what can we do about this? Some of them are hidden. You've got your clear ones, if P, then Q. If P, Q. We've run into that a lot. P implies Q. P only if Q. Those are a challenge to me. I'm going to go ahead and throw that out there. P is sufficient for Q. Q is necessary for P. All P are Q. That's kind of like our vegetable story, right? And Q if P. all of those are the conditional if P, then Q. And we've run into these too, Q, if P, where they're just written backwards, and then you have to fix it. So I have a few of these that we need to try to go from a different language to if P, then Q. Let's see what we can do with this. So I have the statement, this is leap year, implies that next year is not. This is a leap year. It seems like there's an A missing, and there may actually be, but we're going to go with it. This is a leap year, implies that next year is not. How could we write that? So this is one of those implies. Notice the order stays the same. If P, then Q. P implies Q. So this must be, if this is a leap year, then next year is not. Does that make pretty good sense? If this is a leap year, then next year is not. And you could make it more clear, is not a leap year, but that's implied. You kind of see how this works? Let's try this again. No irrational numbers are rational. Now the struggle really with this one is deciding at if it's an irrational number, then it's not rational, or if it's a rational number, then it's not irrational. Okay, now the real if in this particular case is if it's rational. And I know that's hard to see, and I think these are a struggle, without a doubt. I do understand if you have an issue with these, but no irrational numbers are rational. So the setup is, if you're a rational number, then you are not an irrational number. Okay, if a number is a rational number, then it is not an irrational number. And it's a struggle to figure out which one comes first. And even on that one, it's a struggle to figure out which of those situations that I showed you, let me back up to that, applies to this. When you look at it, it's not clear, you know, P is sufficient for Q. That's not really what's going on. I would say Q is necessary for P, I believe is the closest match. Or all P are Q, not quite. I believe this situation, Q is necessary for P is what's going on, because we have, let me go back, we have no irrational numbers are rational. So if you have your rational, then it's not irrational. Very confusing. I do understand this, but I need to go through these and point these out. Let's try another one. Being in Huntsville is sufficient for being in Alabama. How could we write that? My thoughts, if you are in Huntsville, then you are in Alabama. It's certainly not the other way, right? If you are in Alabama, then you are in Huntsville. That's certainly not the case. That's not for the case for us in Greenville. Okay, so, but if you are in Huntsville, then you are in Alabama. Now that one makes logical sense, I think, for everybody. If you are in Huntsville, then you are in Alabama. Let's try a third one. One more time at this, okay? A square is a rectangle with two adjacent sides equal. How could we do this? So an if-then statement. So basically this is saying if you are a square, right, then you have these particular conditions. Because it's saying a square is something. So if you are a square, like if you are a vegetable, then you have micronutrients. Well, if you are a square, then if it is a square, it's not like you're a square, but you know what I mean. If the figure is a square, let's try that, then it is a rectangle with two adjacent sides, because that's what a square is. So let's try that. If the shape is a square, or if the figure is a square, then it is a rectangle that has two adjacent sides equal. What do you think? Now, this is not, I don't say logic is definitely an exact science, but when you're taking the English language and trying to turn it into logic, your words could vary. You might choose different words. But now, this order up here on this one really does matter. But I know it's so hard to see that if you are an irrational or a rational number, then it is not an irrational number. That's harder to get the order right on some of these. I know it's a challenge, but just do the best you can. Hang with me. So let me add another connective to your list. So remember, you have the or statement, the and statement, the negation. Now you have an if-then, and let me add something to it called a biconditional. So here's the definition. The compound statement, P, if and only if. And notice we can abbreviate that by doing, see this IFF that I can't highlight right here? There it goes. Okay. So IFF, when you read that, it's not if, although that would work, but it's if and only if is the way you read that. And that's called a biconditional. And look here too. This is a way that you note it with the arrow pointing in both directions. And I think that's fabulous notation because what it means is if P, then Q, and if Q, then P. So you can read it both directions. So you know a regular conditional statement, if P, then Q, the direction matters. You have to know which one's first. If P, then Q. But now you read it both ways. And so this again is what it means. Wow, my pen, y'all, is just not working. Well, I'm trying real hard to highlight. And it won't. But anyway, using symbols, the conjunction of the conditional, P implies Q, or if P, then Q, and Q implies P is written as. So notice down here, lower left, again, I would love to highlight this, but I can't seem to do it. If Q implies P, or if Q, then P, and if P, then Q, so that by definition, that's what we have. Now, what I didn't do is I didn't prove this using a truth table. Okay, that these would be exactly the same thing, but I'm just giving you the truth table for it, and I want to talk about the truth table. Now, when we go over this truth table, here's what I want you to think about. Your normal if P, then Q, and let's take a look at that. So, if true, then true, remember that's true, because any time you have the P and the Q true, if you start with P, then it's true. If true, then false, remember, was false, okay? If false, then true. Now, for a regular if, then, was true. We'll talk about why that's false this time. And if false, then false, remember, was true. Okay, so the one that's different, the row that's different, and again, once again, there we go, my highlighter's working now. Why is that different? Well, what I want you to do is to think backwards. Now let's do if Q, then P. So if I draw my arrow, remember we were doing that on the truth table, if we draw an arrow from if Q, then P, right? So if true, then true would be true. If false, then true, remember, would be true, but we'd already said it was false because it's if true, then false. It's got to work both ways, and the false negates that. So if true, then false, remember, is false. So if false, then true was true, but if true, then false is false. And that's why that changed to a false. And then if false, then false is still a true statement. Because remember, if you start with a false, it's true, but it's got to work in both directions. So that gives us a slightly different truth table. And again, let me erase all of my marks here so you can follow. So true, true, for an if and only if is true, true false, and false true are false. And finally, false false, this is the strange one, is true. But that makes perfectly good sense, right? Because if you start an if-then statement with a false, the answer is true, and that happens in both directions. Now let's see if we can use this to work on a problem. All right, now, two final examples I want to do where we apply the biconditional. So notice it says it right here. It says identify the statement as true or false. That doesn't say anything about the biconditional. How do I know it's a biconditional problem? Right here. When I read if and only if, and I could use that really cool notation, that IFF, or I could use the double arrows, that they all three mean the same thing. But that's a biconditional statement. Now let's see if we can determine if this is true or false based on the truth value of each of our component statements. So we have 3 plus 1 is not equal to 7. Now, is that true or false? Well, 3 plus 1 is 4. 4 is not equal to 7. That's a true statement, right? Okay. 8 is not equal to 8. Well, that's a false statement, right? If we go over to our truth table over here, or you haven't memorized from what we just talked about, we have a T and we have an F. And remember, this was my P statement and this was my Q statement just by nature of the way it was written. Okay. And this is our situation right here. We have a true for our P and an F for our Q value, and overall that is false. What do you think? Let's do one more and see if you can analyze this argument. Okay, so we have 6 times 2 equals 18. Again, if and only if, that's our biconditional. 9 plus 7 is not equal to 16. So you go ahead and pause it. Figure this out. Okay, so 6 times 2 equals 18. That's our P statement. And I'm calling it P because it's written first. If and only if, and it wouldn't matter, by the way, which one we wrote first. When you're doing biconditional, the order does not matter at all. So just pick one for P and pick one for Q. Okay? And so you have that we're trying to figure out if this P, if and only if Q, is true or false in this particular situation. 6 times 2 equals 18. You know that's a false statement. 9 plus 7 is not equal to 16. Also a false statement. Why? Because 9 plus 7 is equal to 16. So when they put the not equal to, it made it a false statement. Now, false and false. Right here on our truth table, false implies false is actually a true statement. And so that wraps up what we have for conditional and related statements. So remember, you have the conditional, if P then Q. Then you have the converse, which is Missy's reversing it. Then you have your inverse, which is her flip it. And then the awesome contrapositive, which has the same truth value as the initial conditional statement. You flip it and reverse it. And then you've got this crazy biconditional that we just worked on at the end. So I hope you have a wonderful day. As always, let me know if you have any questions. Take care.